And thanks so much for joining us to talk about the Arizona Tri-University Recharge and Water Supply Reliability Project. My name is Kathy Jacobs. I'm the PI on this project, and I will be giving you a high-level overview of this report along with my partner in crime, Neha Gupta, who is the project manager for this whole effort. What we're going to be representing today is the work of more than 40 people across 3 universities. This project was paid for by the Arizona Board of Regents through the Technology Research Initiative Fund. We also were asked to do this on behalf of the Arizona Department of Water Resources, who were interested in finding out if there are more ways to capture water that we might be able to use to offset some of the shortages that we are experiencing now. I am going to go through the agenda next and note that we will be holding questions until the very end because we are recording this presentation. Next. Note that this whole project is in part motivated by the work of Dr. Tom Meixner, who was in fact the initial PI on this project, and so we have kept him in mind throughout all of this effort. What we're going to be sharing today is essentially a high-level overview of the report, including ways that you can navigate through our website to make sure that you find what it is that you're looking for. We'll give you some content along the way and make sure you're very familiar with what it is that we've provided. And then you'll have an opportunity towards the end of this session to ask us questions about how to find things and how we approach different parts of the report. We do have a section on decision support tools that we're going to emphasize, particularly the groundwater basin profiles. Next. We sent out a memo to all of you, basically a newsletter, that was the initial way that we were suggesting that people get access to our report. But if you go to the next slide, we now are encouraging people to go primarily through our website because we have many more ways to approach the materials. And the website itself is available, and I think it's just been put into the chat. It's zcast.arizona.edu /ATUR. In the website, you'll find there are sort of 3 main sections of the final report. There's one which is called Final Report, cleverly enough. But then there are 2 components of that, the executive summary, which is a high-level way to approach all of our findings, including our key messages, and an even shorter version, which is called conclusions. So all of those are components of the main report itself. We also have several tools for water managers and decision makers. One is called the Decision Support Framework. That is really a way to help water managers and people who are within various utilities and watershed management groups to understand how they might actually access our information and how they might put it into their own context for making decisions about how to find out if there's more water supplies available. One of our major products is the groundwater basin profiles. We'll be spending quite a bit of time on that today. And we'll also show you some components of the Recharge Opportunities Matrix. So those are the 3 major tools we'll be sharing. But if you go to the next slide, you'll note that all 3 of those are actually appendices to our main report. But we also have additional appendices. So Appendix A is the groundwater basin profiles. That's where you'll go to find the 51 different basin summaries, as well as the statewide summary. Appendix B is the publications that have been generated by our team to date. They include all the peer-reviewed publications that have come out, and then also a series of published data products so that you could actually see where all the modeling inputs and outcomes are and be able to check in and use the data whenever you want to. Appendix C is the annotated literature review. This is a very resource-heavy component of the document, and it has lots of citations and references, but really gives you a summary, a high-level summary of each of the topics that we are covering in the report. Appendix D is a way to really find out quickly what the background and the evidence is for each of the key messages and the supporting information behind those. So we've given it to you in a very easy table. You can actually figure out who the main participants in our team were, who are behind that message, but also where is the really most important, where are the most important references. Appendix E is the decision support framework. We'll be talking about that more today, as well as the recharge opportunities matrix, which is a list of around 50 or so different opportunities to capture and recharge water in different components of the Arizona landscape. Appendix G is the bios for the researchers who worked on this project, more than 40 people, 15 of whom are faculty, and the rest are either students or postdocs. Appendix H is the Technical Advisory Committee, who graciously assisted us throughout this process and gave us lots of good input. We have a report glossary for those who are interested in knowing how to define various terms, and then a bibliography, which is just a list of all the references that we actually cited in the report itself. Next. So just as an example of the key message approach, within the text, you'll see key messages cited in bold, and then you can click on that bold link and it takes you actually to where the key message is described. And then in this summary table, we have all of the key messages, and this appears at the end of the executive summary, and also it's part of the part of Appendix D. Next. And this is Appendix D, which gives you two additional things. It has the primary contributors from our team, who are the people you could go to actually ask more questions about this topic. And then the final column there is the supporting information. Many of those topics are linked so that you can go directly to the background information. Next. I'm now going to turn it over to my colleague Neha, and she's going to take you on a whirlwind tour of the findings of our report. Thanks.
Kathy, you'll be back on in just a few minutes, so don't go anywhere. So I wanted to start off with kind of the guiding questions of this work and that really underpin the whole report. Really, the questions that we were tasked to answer as part of this project is how and where can we capture and recharge water that is currently lost to evaporation, sublimation, or transpiration to enhance Arizona's groundwater supplies. So really thinking about what are those sources of water that sit outside of our existing water rights frameworks, water that's lost to the atmosphere via these processes. And then we also thought additionally about water that's generated as a result of urban development, thinking about urban enhanced runoff, as well as water that may be generated as part of post-wildfire runoff or flood flows. How can we think about waters that may be a nuisance in some contexts as an opportunity, and how might that present a recharge opportunity? This is really a increasing question across the state. We see groundwater declining or becoming more stressed in areas across the state, leading to the formation or announcement of multiple new AMAs, even since this project was started. However, a lot of these places also don't receive imported water from the Colorado River. They may be very rural communities that don't have, centralized wastewater treatment plants to use effluent. So we're really thinking about what are those opportunities beyond imported water and beyond effluent, and how can we really think about our watersheds in the natural hydrologic system, and what are those opportunities? So next slide. So, part of the question, where can we capture and recharge water? A big part of this was understanding how water moves across our state and how it's partitioned across what we call the natural hydrologic cycle. So, thinking about rainfall in terms of precipitation, evapotranspiration, recharge, and runoff. I'm thinking about where those are highest across the state, how they vary, both in space and time, and we'll get into some of that later. And then also understanding our underlying geology in our recharge context. So thinking about developing spatial data sets that are continuous across the whole state was a major goal of this project. One of the things we did was develop a subsurface infiltration index that you see here in the bottom left. We didn't want to say recharge suitability index because there's a lot of things that ultimately influence whether a place is suitable for recharge. So we're really thinking about this in terms of where are areas that water is more likely to make it into the ground as a result of surface and subsurface properties, including the role of karst, lineaments, and other geological factors. Next slide. We're also thinking about how can we capture and recharge water, especially in the context of existing land and water management strategies. What are opportunities to help increase snowpack, reduce snow sublimation, use erosion control structures or other flood management features to help get more water underground that would have otherwise been lost to the atmosphere. Go to the next slide. Kathy, I'm going to turn it over to you to take us through section 2.
Great. Thanks, Neha. So this slide is really the introduction to our statewide water summary. As I mentioned, we have an individual summary or profile for each of the 51 groundwater basins delineated by the Department of Water Resources. This particular summary is for the entire state. And you'll notice a number of things here. First of all, the amount of precipitation and evapotranspiration across the entire state is roughly equal. This is based on the NOAA MP model. We actually used two separate sets of models. They were very similar, but in this case, there's actually evidence of increase of ET above the total precipitation, and we'll talk about that a little bit more in a second. One piece of information that we have produced here that really has never been available before is the partitioning of evapotranspiration, or ET, into different components such as soil evaporation, transpiration, and evaporation from the vegetative canopy. As you'll see here, the majority of the loss is actually soil evaporation, followed by transpiration or water use by plants. So most precipitation in Arizona returns to the atmosphere through evapotranspiration. Less than 3% becomes groundwater recharge on average across the entire state. And we want to emphasize this is a natural water balance. This does not include pumping. So this is the amount of water coming in and being lost from the system, as well as the recharge and runoff component. Next. So, an important thing to understand is that recharge is not occurring evenly across the entire state. In fact, both recharge and runoff are highly concentrated in the mountainous regions of the state. On the Colorado Plateau, there's some high-level areas with snowpack and fractured and karst terrain. There are areas in the White Mountains and along the Mogollon Rim, and a few small areas in the Sky Air Islands where there are localized recharge hotspots. But generally, what we see is that recharge and runoff is very low in the southwestern desert basins and much higher at high elevation. Basin scale variability ranges from less than zero to greater than 10% of precipitation winding up as recharge. Next. So we have graphs like this one here for every one of the basins, and it's really quite fascinating to see how different the patterns are. But what you do see in general is that precipitation increases during the monsoons, At the same time, as the temperatures increase, and for that reason, you lose a lot of water to evapotranspiration. So the heavy blue line is precipitation, the heavy red line is evapotranspiration, and what you'll see also is that the dotted yellow line, which is recharge, and the dotted green line, which is runoff, are relatively low in the summer, even though that's when the majority of the precipitation is falling. And the reason, of course, is with high temperatures, so much of that water is lost. So we have very different patterns going on in different times of the year. The winter frontal storms are really important for recharge. There is a late winter peak in February to April, where both recharge and runoff are greatest. The summer monsoon, though that does have a lot of precipitation, is not when we are getting the majority of the recharge. Next. I also wanted to just briefly cover some information related to climate change. To my knowledge, this is the first time we've ever had climate change projections available by individual subbasin. In fact, this is by far the most detailed analysis of climate change impacts on water supply availability for the state, at least that I know of. They're based on SSP 370. This is a scenario that was developed for the IPCC, the Intergovernmental Panel on Climate Change. It is a relatively high projection. It involves doubling of CO2 emissions by the end of this century. However, it is not the highest emissions scenario that's available, and it is the one that's recommended for use in trying to evaluate impacts of climate change. What it shows is warming of up to 6 degrees centigrade by 2099, starting in 1981. That's a bit higher than the overall global warming average, which is around 3.5 to 4 degrees centigrade. We're expecting to see recharge decreasing over time because of that increase in heat. And unfortunately, we're seeing that the mountains will have the largest decrease. That's unfortunate because, again, that is where we see the majority of the recharge happening right now. Next. The other component of our climate projections involves trying to understand what's going to happen to groundwater across time. So the climate change projections include a projection of groundwater storage reductions over time, and they actually mirror the amount of water storage reduction, the total water storage, as opposed to groundwater storage reduction. So because we're seeing higher temperatures and we're seeing less recharge over time, we do anticipate losses from the groundwater table, and we're already observing those. That information is reinforced by satellite imagery that we have access to that looks very similar to these graphs. Next. I'm going to turn it back over to Neha, and she's going to talk to you about recharge.
Thanks, Kathy. So we have a number of sections in the report, and what you just saw from Kathy was a snapshot of some of the key messages coming out of section 2. I also want to emphasize that there are many other key messages as well in that section that I encourage you to take a look at, including one of our favorite ones related to the role of base flow across the state in supporting our groundwater resources in our surface waters. So I'm going to be talking to you about some of the work included in Section 3, we call Recharge Across Diverse Landscapes. In our team, we looked at both natural landscapes, primarily described as forested regions, and our more grassland regions, as well as our urban landscapes, and thinking about what types of opportunities exist in these areas and developing some more fundamental science foundations to help support this. So can we go to the next slide? So one thing that I perhaps should have noted is we're really thinking about all of this in more of a holistic landscape management, watershed scale type of system. And one of the things that really underpins all of the work that's being done in Section 3 is thinking beyond managed aquifer recharge in a term that we called opportunistic recharge enhancement, or what I like to call an all hands on deck approach to recharge. So, beyond thinking about recharge as your primary management goal, the way we do when we recharge Colorado River water in our large basins outside of Tucson, instead thinking beyond that into how can recharge considerations be integrated into existing land and water management activities to both increase water available for human, but also our environmental systems, which are being increasingly threatened across the state, particularly by the warming that we're seeing. This is a framework that can be adapted across multiple areas, can be brought down to size and a region, and really thinking about the role of activities like forest management, flood control, post-wildfire management, and also putting in a plug for thinking about the way we manage our roads. There's a lot of different opportunities to think about given the diversity of landscapes and climates across our state. Can we go to the next slide? There is a publication related to this that is open access, published in the journal Groundwater, that goes to the framework in more detail. It's also linked in our newsletter for easy access, and we'll make sure to put that into the chat as well. Yeah, next slide. So some examples of things that we're talking about when it comes to recharge enhancement is the use of these pond and play structures, pond and plug structures as a result of post-wildfire runoff management. A lot of these are typically implemented in high elevation regions and areas that are pretty mountainous that may have increased connectivity to groundwater. There are, of course, water quality considerations to keep in mind that can be addressed through planning and engineering, but just thinking about what are some of the quantities of water that might be available through different management. A lot of this work was also informed by what's been done in the Upper San Pedro in terms of using a diversity of structures and strategies to help increase recharge in that area to support the riparian health of the San Pedro River. They have a lot of projects that have been going on for many years, and one of the best things about what they've been doing is collecting data along the way to show how these features function across time and also across dry and wet years to help us better understand how to optimize them and perhaps lead to better quantification down the line. The other thing to note, here on the right side, this might be an esoteric road diagram, but it's here to remind me to say that, there are also ideas out there in the literature that haven't been as tested on the ground, but we think can present really interesting opportunities. One of them is this concept of using roads to help increase recharge, especially where roads are cutting across hill slopes, may experience flooding that result in road closures and nuisance flooding, but that there are some simple engineered structures that can be integrated into this road building and road management to help get more of that water underground. Can we go to the next slide? A lot of what we did in this project involved the use of suitability analyses. So going back to the where can we do this? We did a few different suitability analyses, especially focused on looking at forest thinning and then flood enhanced recharge. I'm not going to bore you with all of the details that go into conducting this suitability analysis. It's a form of analysis called a multi-criteria decision analysis, where you basically stack together a bunch of layers, you give them different weights. This noodly diagram on the right side is what we call a Sankey diagram that shows some of our layers and how they're combined in different weights to develop a forest thinning suitability index. That's what's shown here on the left. We did this for across the state, really focusing on the Ponderosa pine forest. So you'll see a lot of the areas are kind of focused along that Mogollon Rim region, thinking about where can forest thinning be integrated into recharge efforts. And this is just an example. It's also listed in our publications and our data sets and in section 3 of the report if you'd like some more information. And then the next slide. Another thing to highlight from section 3 is that we're also thinking about the role of karst and fractured terrains and how they can help support recharge, especially in the northern parts of the state. These are areas where water can really quickly infiltrate underground and move through these kinds of pipe-like features in our karst, which are shown in kind of this infographic here on the left. The other thing that we developed was a lineament density map for the state of Arizona done by Ryan Lima that helps us also look at where are some of those areas with increased lineament density that can be indicators for high recharge areas. Go to the next slide. One thing to also note, especially because we're talking about reducing atmospheric losses via evapotranspiration, is that we understand and we also want to note that it is really critical to maintain healthy environments and ecosystems that underpin the ways that our natural systems function and get more water underground. So something we've also included in our report is a guiding principles for enhancing both recharge and habitat. These are some of our high main points. There's multiple kind of sub-bullet points under all of these in our report. But, maintaining and enhancing natural hydrologic system function is a critical piece of all of these types of strategies. Supporting healthy forests, limiting high intensity wildfires that can really be destructive to the ways that our ecosystems function after the fact, encouraging recharge in naturally suitable areas, and also conversely, protecting areas of high natural recharge. Acknowledging and accounting for water and the maintenance requirements of enhancing our environment and habitat quality in the way that we manage our water, we also think is really important to keep in mind. Can we go to the next slide? So I'm just going to keep on talking to you guys and take us through section 4. One thing that I neglected to mention at the beginning, but Kathy covered, was that a lot of what we pulled together was not just a scientific foundation, but organizing it in a way that we hope will be helpful to support decisions across the state in the ways that we think about managing our land and water. There are a few different things that we've developed, including what we call a decision support framework, or what we call the DSF for short. It's a multi-step kind of process or flow chart to think through where our findings from our report may be helpful or applicable in your region or your neck of the woods. There is both a PDF that has been developed. There's also an interactive story map, which I would actually encourage you to start at because you're a little more able to interact with some of our layers and maybe think about how it might apply to some of your goals. Can we go to the next slide? So this is an example of some of the interactive dashboards that are on the story map that are linked in the website that Marlena just put into the chat. So there's a lot of data sets, kind of like you saw earlier, related to our hydrologic cycle, surface and subsurface properties, and some of their suitability analyses that you might want to click through in your region of interest. Go to the next slide. And one thing that we really encourage you to take a look at are the groundwater basin profiles that have been developed. These have been developed, as Kathy mentioned, for all of the groundwater basins across the state, the 51 groundwater basins, which I'll note are distinct from the 83 groundwater subbasins. So if you're looking for your neck of the woods, you want to make sure that you start with your groundwater basin. So page 1, we're just going to talk through each one of these pages. Starts with some of your summary statistics, especially pulled from our NOAA MP hydroclimate modeling, which include your mean annual water balance. So that diagram with down here with the blue line and the red line, thinking about how that changes through time. Especially we see in most of our basins across our state that recharge is peaking in winter time or early spring. Taking a look at for your neck of the woods, what does that look like? And also looking at on whole, what does your natural hydrologic cycle look like according to our modeling results? Marlena has also taken the time to painstakingly write up a little interpretive blurb on every single one of these profiles to help summarize some of this information. And next slide. Page two shows more of our spatial information. So you saw the maps that Kathy presented with what does the state look like on whole. But what we've also done is rescaled that data to each individual groundwater basin so that you can see within your basin what might be those hotspots of rainfall, of ET, those typically especially in line with the mountainous regions, what might be some high areas of recharge and also runoff. I'll also note that runoff in these models is defined as the areas as where runoff is generated. We also have the rescaled version of the subsurface infiltration index, the thing that we're not calling a recharge suitability index, but gives you that type of information. It's also summarized in the little blurb on the bottom right as well. Next slide. Page three includes summaries from our climate change projections that Kathy mentioned earlier. So we've downscaled 14 global climate models. And so what you see is kind of that envelope of where the 14 climate models were. And then the bolded line is the mean of those models. So you can see that for some of our predictions, there is a lot of divergence in what some of the models predict. You can see where the divergence is in precipitation, especially in kind of that late summertime that, that's an area that there's a lot of uncertainty in the models. So we've provided that type of information. We've also overlaid the means of each of the climate models into one figure as well, so that you can kind of see how the magnitudes of change stack up together. And go to the next slide. And then on the final page, page four, is a little bit of a narrative, a little bit interpretation of how these climate change projections apply to this basin. Some of the things that we're seeing pretty consistently across the state is an increase in that late summer, early fall rainfall associated with tropical storm activity. We're seeing reduced recharge in our winter, early spring, also due to reduced snowmelt, potentially due to rising temperatures. And then we also have a list of references available that were used to develop the profiles. So we really hope that you take a look at these. A lot of work went into them and trying our best to bring all of this information into a format that might be able to be helpful for more regional or specific planning efforts. In the next slide. So we also talked about a recharge opportunities matrix. This is a matrix that I'll show you in the next slide that includes a number of different strategies that haven't been, I would say, fully investigated in the scientific literature. A lot of them come from many different areas. These are things that we say, these might also be worth thinking about what are the opportunities, what are some of the trade-offs. We used to call this the out of the box matrix. So, really just trying to assemble a lot of different ideas that might be something worth exploring or thinking about. They're organized primarily by landscape type. So, thinking about our natural landscapes, your forests, your grasslands, open water bodies, urban areas, rural and developing areas. There's all kinds of different headings. If you go to the next slide. So this is an example of what the matrix looks like. So here we're in the forest section. So thinking about the role of fuels reduction and forest thinning, erosion control methods, what are some of the opportunities associated with that? And then what are some of the things that might be constraints, limiting factors? What are some unintended consequences that we might want to think about ahead of time? And next slide. All right, now I'm going to turn it back over to Kathy.
Thanks very much, Neha. Good news for all of you is that we're nearly at the end of our presentation, so I hope you're getting your questions ready for us. So we wanted to really bring home a few really high level points that may or may not have come through so far. First of all, warming is having a profound effect on water in storage. We're seeing evidence of essentially dewatering our groundwater systems as even with as much climate change as we've seen so far. This is an important concept to take into account, given that there's really no doubt that warming will continue going forward. A second point is we do expect extreme events to intensify. We're talking about both droughts and floods. And as Neha mentioned, in the fall or late summer, we may actually see some more intense storms that might be a big opportunity if we are ready for them when that happens. Of course, it's not a big opportunity if we're not ready. And so a lot of this has to do with being adaptive and prepared for the changes that are coming ahead of us. The third major point is 32% of surface flows in the state originate with groundwater. What this means is the intersection between groundwater and surface water flows needs to be taken into account. If we have a reduction in recharge, we will have a reduction in surface flows in many parts of the state. Obviously, these systems are highly interrelated. The fourth point is we have identified a large number of potential options for capture and storage of water, including the opportunistic recharge enhancement idea. Many of these may be very low-cost solutions because they are essentially add-ons or co-benefits to work that's going on anyway. So, for example, forest thinning is going on across the state already. If you do it a different way and just focus on a recharge objective in addition to a fire objective, you may well seriously increase the amount of recharge associated with that particular project. Urban development can include capture opportunities. This is a really important point because wherever we see pavement, we see an increase in runoff, and it matters a lot what happens to that runoff. If it can be captured in detention or retention basins, if it can be slowly released into an ephemeral stream or an aquifer, or if in the process of doing the urban development, we can ensure that we don't pave over the areas that have the highest recharge capacity, all of these will really help contribute to water supply potential in the future. And then finally, a point that Neha already made, but I'd like to remake it. We're seeing a lot of impacts on the natural environment across the state already associated with warming and drought. And in fact, we can't do our water supply solutions at the expense of the environment. We already have seen great damage to biodiversity, reductions in stream flow, lots of losses. And it's pretty important that these environmental assets be taken account of and that they be protected going forward. Next. So we have successfully reached the end of our presentation. I want to encourage you to explore our website and all the individual cards that we mentioned earlier. We do have future webinars scheduled. We have one with the Water Resources Research Center, August 13th, and that was one that you need to register for, but that's an easy thing to do online. We also are presenting topical individual webinars that are more in-depth across in a series across the fall of 2026. We'd like to suggest that if you have any interest in working with the three state universities on these kinds of projects going forward, that you take this opportunity to check in with us at any of the three universities. The lead PI at Northern Arizona is Abe Springer, and at Arizona State is Giuseppe Mascaro. We are in the process of transitioning to phase 2 because we actually successfully met all the conditions of our phase 1 contract, turning in this report in June. We will have one more year in which we have some of our PhD candidates continuing to work in finalizing some of the research that we've been describing to you today. And Neha is going to be taking over as the PI for this project from now on. So we are incredibly grateful to have such a talented person already sitting there in the driver's seat, ready to take off. So thank you, Neha, for your agreement to take over from me in being the PI. I also want to thank Marlena Hinckley, who we basically threw in the deep end 2 years ago, and she's been swimming incredibly hard ever since. She's been a critical part of our management team, and she is going to start swimming in other pools in the near future. But we are incredibly indebted to you, Marlena. We're also going to be adding a management team member, Kalim Rosnick. I don't know if Kalim can turn on his camera or not, but he is joining the management team. He recently completed his PhD in Northern Arizona and will be part of the management team going forward. If you have questions about our project, here's our contact information. And with that, I think we'll go back to the not sharing version, and then we can see your faces. And if you have questions, feel free to put them in the chat, and we'll either that or you can just shout them out if you don't have any questions in the chat. Are there questions in the chat?
Yeah, there's a couple things in the chat.
Okay, great.
The first one is from Walter. How is climate change affecting evapotranspiration?
So the direct answer to that is that when you have higher temperatures, you have more evaporation. And one of the reasons for that is with higher temperatures, the atmosphere holds more moisture. So it's basically sucking moisture out of both plants and soils, and causing us to lose access to water supplies on the ground.
And then there's a more of a comment from Thomas of many downstream water users have historic legal water rights to surface flows. This would appear to have the potential to significantly impact many of the proposed water capture and recharge schemes and could result in legal actions to limit them.
I'm happy to answer that. Would you rather, Neha, or would you want me to?
I know that we've been thinking about this from the very beginning, so let's
Yep,
have
day
you kick it
one.
off.
Sure. So this issue is something we're extremely familiar with, and we have deliberately designed our entire report and approach around the idea of not interfering in any way with surface water rights. It's one thing, obviously, to divert water from an existing natural channel. That is not what we're suggesting. What we're talking about doing is capturing water that would not have made it to a natural channel because it's being lost to the atmosphere. So we're essentially talking about a new source of water that did not exist before and is being created either because of capturing water that's currently lost or capturing water in the context of urban development that was not previously entering a natural channel. And so we don't see that there's any conflict actually with surface water rights, and have worked pretty hard to avoid that and be pretty explicit about that throughout this report. Do we have other questions?
Those were the two that we had. Are there any more from anyone in the audience?
Feel free to just unmute and ask. We seem to have some time.
Kathy,
Caitlin.
and go ahead. Is Trace going to talk first? This is Val
No,
Little.
I think you're talking.
Okay, Kathy and Neha, can you speak just a couple sentences more about what you hope to accomplish in phase two?
Sure, I'll
So,
turn that over to Neha.
sure. So one of the things that we are doing, well, I guess I'll back up. So phase one was really focused on, conducting the work that you just saw. And with our no cost extension, we're really calling that phase 1.5, in that it's really getting a lot of our students through that are doing work and continuing on work that was opened up in the first phase of the project. What we've learned from conducting this work is that one, there is a lot of appetite, especially on behalf of our researchers across our universities, to continue to do work that keeps more of the benefit of the state in mind, a lot more applied type of research. And we've opened up a lot of cans of worms, so to speak, of areas that we think could really benefit from additional work. Some examples of that include expanding monitoring across the state of groundwater levels, of pumping levels, of evapotranspiration. We leave a small handful of observations across the state. Another is better linking and characterizing opportunities and science related to extreme events and recharge. We're seeing that on average, we're expecting recharge to decrease, but there's going to be some very distinct times and events that present a great opportunity that we can get in front of. And so thinking about how do we build out more information related to predictions, related to strategies to advance that line of work. There's also work related to, increasing better representation of some of our plants, especially our mesquite. So those are some of the examples. Some things that are a little less scientific in nature are working with communities or planning efforts to see how we can bring some of our ATUR findings and products down to scale to help integrate these planning processes more directly. And then also just a little bit of continuing to communicate about this project and some of the findings because there's a lot in there and we understand that there's a lot to just kind of navigate. So those are some of the things that we're really focused on more immediately for what we're calling phase two.
Thank you, Neha. Thank you.
I'll go to a question from Mead Meyer. The question is, have you gathered interest from ADOT or local departments of transportation in the road nexus? And that's a great question. What we have done is suggest a number of potential partnerships that could develop over time. We have not worked explicitly with ADOT, but one of our deliverables was actually suggesting ways of developing partnerships around these projects. But I think we're hoping that sort of takes off and starts snowballing, and we're happy to work in partnership with anyone who's interested.
And I saw Caitlin had her hand up.
I think
I
she already, go
yeah,
ahead.
I dropped it in the chat since it was easier. But my question was, what do you think are some of the big takeaways, or like the one or two things that you would want to make sure that water resource managers know, especially as they're planning for CAP cuts and things like that? Like, what are the big take homes or things that you would want them to look at as they're making these plans, looking ahead?
Do you want me to go first, Kathy, or how?
Sure.
I think, with this project, this is one piece of the whole portfolio. So this is more focused on that water supply piece, better understanding the natural hydrologic system. So I think some of the big takeaways, especially in, municipalities, are thinking about how to work with flood control districts, how to, do your development and planning processes in a way that you protect your high recharge areas from development. But all of these strategies have to be combined with, within a multitude of strategies, including water conservation, more of that demand management. And so it's one piece of the puzzle, and I would say it can help, increase some of the slices of the pie, but it really has to be integrated within a much larger suite of strategies.
And I guess I would reinforce that, but also say we are looking towards a future that's going to be even more challenging than the one that we're seeing today, which is not news that anybody wants to hear. But we're also saying that there really are lots of new ways of framing sort of existing practices so that we can benefit from things that are going on anyway and really have an enhanced water supply in some regions. I think there are some regions where it may be very difficult to make much of a significant difference, but there are others where it probably is likely that the water budget can be significantly enhanced through these techniques.
Then there's a number of questions in the chat. But I don't think that we answered Trace's question. Do we think the ATUR report represents the full range of water options for Tucson, or are there other things we should consider? I think the simple answer is that it definitely is not the full range of options. Kathy, do you want to?
Yeah, and I think the best way to look at this report is it is a scientific foundation for decisions that can be made going into the future. It's not intended to be the end all and be all final word on really anything, but it is intended to bring all of the latest information to bear on this particular problem, and set the foundation so that people can start from that point to refine solutions for their own utility or region or company. Um, so we're not making any specific recommendations. We're simply trying to support the work of other people.
And another question in the chat, runoff from urban and industrial areas can have water quality issues. How might these be addressed?
That's a really great point, and we're very aware of that. Clearly, there needs to be testing of the water quality before there's a design stage when you're trying to get water into the aquifer. That's particularly important if you have karst topography or a really quick way to get an aquifer recharge, such as through lineaments or fissures in the land. So it matters greatly how you recharge and of course what the quality of the water is, what is in the water to be recharged, and that will require more monitoring. There is no doubt that we need more groundwater level monitoring. We need more groundwater and surface water quality monitoring to enhance our ability to use these techniques.
And I think overall, I see water quality issues as something that, has a lot of potential to be addressed with engineering and environmental engineering types of strategies.
Mhm.
So some of the other questions we have are many recharge efforts involve drilling a deep hole wherever practical, not necessarily in the best location for recharge. Do you think this study will provide enough support for municipalities to invest in more costly but more efficient recharge locations?
Well, I think what we are doing is providing regional templates and lots of ideas. I don't think we're giving any one municipal utility sort of a recipe card for how to bake their own cake. That being said, we did, for example, find that dry wells are a much more effective way to capture flood flows than at least I understood previously. The volume of water being captured by dry wells in the Phoenix active management area is very large. So, depending on what utility you're talking about and the geology in that location, there's lots of opportunities, but there are different opportunities depending on, your source of water, the seasonality of the water supply, what the geology is like, etc.
So I'm going to go to groundwater storage is impacted by both recharge and groundwater pumping and other groundwater discharge components. Does your 100-year groundwater storage declining trend reflect both impacts or just 100-year recharge decrease impact?
Well, our modeling did not include pumping. Our modeling is based entirely on the natural water budget. So we are, in fact, reflecting changes associated with evapotranspiration much more than anything having to do with pumpage.
I think that's reached the end of our questions that we've gone through.
Anyone else? This is your last chance. Not really. We're available. But anybody have any other questions you want to ask?
I have a question. You
All
brought
right.
up the decision support framework, but you didn't talk about it in depth. Is there another chance for people to learn more about the decision support framework?
I think she's a plant. What do you think, Neha?
Yeah.
Go ahead, Neha.
So we have a number of other kind of webinars coming up, some related to this was really meant more of an intro or a guide to the products that we've recently released. We'll be presenting to the Arizona Cross Watershed Network, groups of watershed groups and practitioners across the state, really tailoring some of our information more for that audience. With the WRRC webinar in August, we'll be talking at a more specifically about some of the findings that we think will be more relevant to, that audience. And then beyond that, kind of similar to this webinar where we're kind of hosting it within the project, we'll have a series of, I think, about 4 other webinars digging into more of the under the hood of the science and of the individual pieces of the report. So the decision support framework will have its own webinar that will go more under the hood and step through a few use case examples. I believe we have a webinar that's really focused on, estimating evapotranspiration and the base flow index development and some of those more scientific studies. So we'll have a number of those coming out for you to keep an eye on. And if there's something that you're more specifically interested in, just please let us know.
And thank you, Kirsten, for setting up this webinar. We appreciate it. Anyone else? Last chance this time. Okay, well, thank you so much for joining us, and keep an eye out for future events. They will be posted on our website, and I'm sure that you'll be interested in joining more of them. Thanks very much.
Thank
Bye.
you for joining today.